Hi everyone. Today I'm going to explain about Snowflake and its fundamentals. What is Snowflake? Snowflake is a cloud native data platform that let organizers store, process, and analyze data efficiently without managing infrastructure. Snowflake is a fully managed, means no servers to install or manage or maintain, and cloud native data platform means it is built exclusively for the cloud and provides an end-to-end system to store, process, analyze, and share data without managing infrastructure, and built for analytics, data warehousing, and seamless data sharing at any scale. Means analytics means ask questions about your data, and data warehousing means store huge amount of data in one place, and data sharing give other company access to your data safely. Share sales data with your vendor without emailing Excel files. And Snowflake does not have its own servers, it sits on the top of existing cloud providers. So it runs on AWS, Azure, GCP. So AWS, Amazon Web Services, Azure, Microsoft, and GCP, Google Cloud Platform. And you just pick one when you sign up. And why Snowflake is different? So I said fully managed, so no servers to install or maintain. So Snowflake managed everything. And separated storage and compute means in traditional database bases, storage and compute are tied together. If you need more power, you buy more of both. Snowflake separates them so you can scale each independently and save money. And auto scaling means, so during heavy traffic, Snowflake automatically adds more compute. When traffic drops, it scales back down. No manual tuning needed. And pay per use. So you pay only for the compute seconds you actually use. If nothing is running, you pay nothing. And Snowflake follows three-layer architecture. So first layer is database storage, and second layer is virtual warehouse, and third layer is cloud services. So first one is database storage. So this is where your actually data lives and stored in cloud. So AWS, Azure Blob, or GCS. So virtual warehouse means this is the engine that runs your queries. It reads from storage and processes your SQL queries. And cloud services means authentication. So it handles login security and query planning and metadata. It coordinates everything. So first we talk about database storage. So database storage, so columnar storage. So data is stored column by column, not row by row. When you run a query like select average salary, so Snowflake only reads the salary column much faster. And micro partitions. So Snowflake automatically splits your table into small checks. So 50 to 500 MB. Each check has metadata. So Snowflake knows which check to skip when running a query. And automatic compression. So each column is compressed using the best algorithm for its data type. This reduces storage cost significantly and sometimes up to 70%. So, and no index needed means in traditional databases, DBAs spend hours creating and tuning indexes. In Snowflake, micropartitions metadata does the job automatically. And warehouse. So a warehouse is a compute layer. It provides CPU, run SQL queries, load data, transform data. So storage is separate. Warehouse only computes. So independent clusters of compute resources. Each warehouse has its own compute. One warehouse does not use another, and warehouses CPU or memory. And multiple warehouses can run simultaneously many terms and can work at the same time, no waiting for resources. So in database storage, we are storing data. In virtual warehouse, we are running queries. So virtual warehouse are the compute engines that executes your SQL queries. So they are independent cluster of compute resources. Means independent cluster of computer resource means each warehouse has its own compute. One warehouse does not use another warehouse's CPU or memory. And multiple warehouse can run simultaneously means many teams can work at the same time, no waiting for resources. And each accesses at the same shared storage layer means so each access at the same shared storage layer. All warehouses read write from one central storage, so no duplicate data. And zero query performance impact between warehouses means queries in one warehouse do not slow others. And warehouses sizes, each size doubles the compute power of the previous test. So in warehouses there are different sizes: XS, S, M, L, XL. These are the warehouses sizes. So for small you need for XS, and for large amount of data you need L or XL. You can use L or XL for huge amount of data. Next, cloud services. So it is the main thing, the intelligent backbone that coordinates everything in Snowflake. So first one is authentication and security. So authentication and security means, so while we sign up in Snowflake, it asks for username and password. And after that, it has two verifications, so two lock instead of one. And IP whitelisting means only allowed address can enter. And encryption at rest and transit means data, so encryption at transit. So data is safe while traveling, and encryption at rest means data is safe while sitting or stored. So query optimization means you just write what you want. Snowflake figures out the fastest way to get it, no manual tuning needed. And metadata means, so as of now I said tracks, partitions, statistics, and schema definition to enable instant tuning and planning. So it stores metadata, so what information in the in checks what information is there, it stores everything, it gives a fast result. And transaction control means every group of steps either fully complete or fully cancel. Your data is always correct, consistent, and safe no matter what happens. And auto suspended and auto resume, so stops when idle. If no query for a set period, if no query runs for a set period, the warehouse automatically suspends. You stop paying immediately and start automatically when query runs. And cost optimization, no charge is required while the warehouse is suspended. And databases, schemas, and tables. So this is the logical hierarchy in Snowflake. So database in the top container, schema sits inside the database, and table lives inside the schema. So first we need to create a database, in that we need to create a schema, in that we need to create a tables. So customer table, order, products, analytics. So these are the tables we are creating in schema. So next we are talking about RBAC, role based access control. So role based access, how it works. So privileges are guaranteed to roles are assigned to users, user inherit all roles privileges, roles can be hierarchical. So roles assigned to users. Then you assign the role to your user. The user inherits all the permissions of that role. And improve security. If someone job changes, you just change their role. No need to manual revoke each permissions. And access given to the role means instead of giving permissions directly to user, you create a role and assign permissions to that role. So here roles example, analyst means select only, means the analyst can read data and he cannot change. So analyst cannot change or update data. And developer select, insert and update. So read and insert data. So developer cannot access to delete data. And admin full database control. And Snowflake at a glance. So scalable. So handles gigabyte to petabyte compute scales up or down in seconds based on demand, and secure end-to-end encryption, and cost-effective pay-per use, and zero maintenance, fully managed, no infrastructure or no software needed, and fully managed by Snowflake only. So now I am showing in a practical way. So how to log in Snowflake, the two-step verification. So here Snowflake AI data cloud. So click on it. So here you are seeing the Snowflake page. So here sign in. So select an account to sign in into. So see. So here username and password. So the username and password is must, and sign in. So in this, how we are creating database schemas and tables. So you need to go to projects and workspace, and so here you can create a new database. So create C, so create database sales. So this is your database. So the syntax is create database name to create a database. So you can run the query. So database is successfully created, and now you need to create a schema. Create schema name.